This computer. Hello, welcome again to session number 12, which is basically the last session of this series before we start again in August. The second half of August, we will not restart the session, but we'll come up with new sessions, follow-up sessions, since we still have a lot of topics where we can go much more further than we already did. And since, of course, there are also a lot of topics that we still need to cover. Today's session...
Is it authorized in the network?
Authorized in the network? I didn't do that. You should have been authorized in the network, yeah. Oh, wait. You should, now you should be authorized. Okay, sorry for that. Right. So this session is like what I would love to call introduction to many of the sessions that will follow in the future. This session is about interacting with AYS, so using at your service or working with at your service. That's the official title of this session. We will explain you how you can use AYS to get things done in the system. I will start by explaining you and going over to how you have been already using AYS services, at your services in a very explicit way and also in an implicit way. So I'll be covering both of that. And then I will be showing you a lot of demos on how you could use it, for instance, to talk against the Open vCloud. Yeah? I'll explain you how it works. I'll do a demo on it. And I'll also show you the code, not in too much detail, but just so that you understand very well where all the code is. That makes at your service so self-healing and so intelligent. We'll also show you, and that's part of the demo that we are basically still preparing now, so stay tuned, where we will be showing you a small demo, a small example template, an at your service template that you can use then to talk to the orchestrator. Specifically in that case to launch a container. So launching a container, that's something we have been doing already a lot of times during the previous demonstrations and sessions, through using Insomnia in order to talk to the REST API of the orchestrator. The point, of course, is that we typically will be calling into this REST API, not from within Insomnia, but of course you will be using client applications, or more specifically, you will be using at your service. So you need to create an at your service, as we call it, that does do that all for you. And we will show you how you create that so that at your service can manage all the work for you. Yeah? What I did also do here, I've been updating a little bit the names of the sessions. So now they are numbered, which is nice already, of course, in the slide deck. But most importantly, also at the level of the YouTube channel, made sure that it's very clear what the numbering is. So we have the same titles, so a little bit of detail that in order to make sure that nobody gets confused. Huh? Good. What I will do, I've prepared a lot of stuff, but not immediately in the slide deck. That's something that I'll have to do as a follow-up, which I will. What I will show you now is a presentation that I've been using in the past for introducing at your service. So let me start by doing that. This is a rather old presentation, but I think it's a beautiful presentation that allows me to nicely explain what at your service is. And as you can see, it was prepared a long time ago for a sales audience. So it should be very easy for you to understand what I'm about to convey as a message. Huh? There we go. What is at your service? So you also remember, I should include that again in this slide deck, that I already have shown you an official definition of what at your service is. It's a system for managing the full life cycle, yeah, of both the infrastructure and of any workload. And as I said already before, at your service could basically use to manage anything. It's a framework for managing anything. Typically, it's used to manage the life cycle, the full life cycle of something. The something typically is like a workload, like an application that typically includes like multiple virtual machines, multiple containers, probably a gateway, 2 gateways, a zero-tier bridge, all kinds of things that typically make up an application or a workload. And then, of course, you need to deploy the workload and you need to monitor the workload. You need to manage the full life cycle. And that's actually what Azure Service is all about. It provides you a system. I intentionally use the word system here because it's multiple things. But basically, the core is what we call an AYS or an Azure Service server. So it's a server application that then does do all this. So typically you need to feed it information, and based on the information you feed it, you will do the provisioning, the self-healing, the auto-scaling, or what we typically call the management, the full lifecycle management of your workload. Of course, you need to feed it, and in that, from that perspective, it's kind of funny that the next slide is about hamburgers. There is, of course, no relationship at all with hamburgers, but back then at the sales kickoff, we used that metaphor to explain what it is. Let me show you what it is from a high-level perspective, and then during this session, you will learn how to feed Azure Service in order so that it understands a blueprint, and so it understands what to do with it based on the things you provide in the blueprint. We'll come back on that at length. Yeah? So the metaphor is about a hamburger restaurant, and at the right side you see a cockpit. When you see the word cockpit, and I'll come back to that many times during the presentation, the cockpit is just another name for what we typically call today an Azure Service or an AYS portal. An AYS portal is, well, just a client. Like we have other clients, I'll show you other clients too, like the command line tool is another example of a client to the AYS server. So that's the metaphor. You will understand in the middle, immediately what it is. The cockpit, of course, is much more visual than what you have with the AYS server, and especially much more visual than what you have with the AYS command line tool. You'll see all that during the session. So in the kitchen, typically you have two things. You have orders and you have recipes. So orders is like somebody comes by, says, I want a hamburger, a Big Mac, whatever, with a menu, with the Coke and mayonnaise. It specifies the order. And then the other side, in the kitchen, they have recipes. They know exactly what people mean when they say, I want to have a Big Mac menu. For instance, then they know, okay, they need slices of tomatoes, they need some bread and some cheese, and whatever is making up whatever is specified in the order. There is a relationship. And the cook knows what to do. He knows what to do based on the order. He checks the recipe, and he is going through a workflow, you could call it, to create the delicious burger. I still like the picture. It took us a time to create it, but it's still okay, I think. And in the cockpit, the same idea goes. In the cockpit, you have blueprints and you have actor templates. A blueprint, what is it? It's an order. It's like, you know what, at your service, here is what I want you to do for me. It's a declarative description of what I want, not on how I want it, but just specifying what you want. So it's like, give me this. That's what I want you to do. And then the cockpit, based on templates, and sometimes we talk about actor templates. It might confuse you, but at the end of the day, just remember, when we say Azure Service templates, we typically mean actor templates, or sometimes we talk about actors, depending on with whom you're talking. Some people will talk about actors, some others will talk about templates, some will talk about Azure Service templates. It's all about templates. The equivalent of a recipe. So Azure Service or the cockpit needs to know how to interpret the blueprint, and needs to know, based on what is in the blueprint, what to do. And that's what an actor is all about. That's what a template is all about. And that's what we will show you today, the templates. And I'm going even to show you an example template, which was just created for the demo for today. Yeah? Good. And then you have, again, some sort of workflow. You have the at your service engine, you could call it, which is basically a server. The at your service server knows what to do based on the blueprints and based on the intelligence, the knowledge he got from the templates what to do. And the pictures you see there, I'm not going to zoom in on it into detail, but it's a real example of what is happening. Each block that you see there is what we call and we have been showing that already before, an at your service service. And you might remember, and I'll come back to that in my demos, you might remember that, for instance, if you were deploying, for instance, a node, that automatically a node service got started, but not only that, automatically also, for instance, a storage pool got started. And you didn't specify explicitly that that should happen. So that means that there is like an implicit relationship or a dependency between then the storage pool service that got started on the AYS server and the node service that got started on the AYS service. So some of the services, the lower you go, are typically dependent on the more explicit started services. And the nice thing about that is this relationship is known by the system. So it knows when something goes wrong in the hierarchy that is being visualized there, that there are consequences up, and that probably then the system needs to check in the lower end of the hierarchy what is wrong. And that's basically also how we can explain that things get self-healing. The system is typically able to find the root cause of problems. So if something goes wrong at the node level, he knows that he probably needs to check, for instance, storage. He will probably need to check other things he gets from this dependency tree, as we call it. So this is the way we try to explain it to show how things are the same thing. And yes, just for your information, these templates, typically we make them available on a marketplace or whatever, a hub, registry, somewhere, just like we have for the F-lists and for the images, we share them on a hub, or we could share them on a marketplace. You could share them privately, internally in your company. It's also basically some kind of intellectual property. For the idea is that for any workload you could come up with, you will have to create an actor. And an actor, as you will see, or templates, is a bunch of files, basically 3 files, that include exactly what the system needs to do to interpret blueprints and to manage the full life cycle of the service for which you have been creating the actor templates. And yeah, this is typically something that can get as sophisticated as you want. It can also be very simple, as the one we will be showing you today. But clearly, if it's a simple one, it will probably only help you to do the provisioning, the initial provisioning, which of course is fine for a demo. But for a production environment, you will also include in the code, because it's about Python code at the end, all kinds of things to monitor every single aspect of the system and learn the system what to do when things go wrong. Good. Well, we sometimes use the word pilot. Well, pilot is typically somebody who feels good using Python code and knows, for instance, how to talk against the orchestrator, knows the API calls, and knows how to create an actor template that was specifically conceived for a specific workload. So it's typically the job of a pilot that does all that. Good. And here you see it again, what I explained. There is some kind of dependency tree or a workflow. In order to make this menu, you need to create things like that, and there is a dependency tree. And that's why it's so nice to explain also there. For instance, what we visualize here, it's a real example. It's an own cloud instance, something like a Dropbox, let's say. And the Dropbox web application needs a caddy server for HTTPS or needs MariaDB. And at a lower level, then you see that some of these things run on Docker containers, and some other stuff runs in virtual machines. And at a lower level, you typically need a place where you can deploy all this, where you can host all this. And that's basically what is all included in the template. The template knows, the recipe knows exactly, the dependency tree knows exactly the workflow, what he needs to do in order to get to the final product. That's the whole idea of this. And here you see a simple example, and we'll be using this simple example, by the way, in my demo. We define here what we call a virtual data center. So the structure of a blueprint is always like this, as you already have seen in, for instance, the blueprint we have been creating for the configuration service and the bootstrap service. We'll come back to it. Remember that one? We already have seen a few examples of blueprints. This example of a blueprint is for creating a virtual, it's for creating a Dropbox kind of a solution, which we call the My Own Cloud. Let's go here. That's the name you give it. And before the double underscore, you then typically see the name of the blueprint. Sorry, the name of the template. So the name of the template, underscore, underscore, the name of your instance. And then you say, you know what? I need this own cloud instance to be run in my VDC. The VDC is my VDC, which basically refers to the my VDC, which got specified here. And this is an error. A V is missing. So it's based on the template VDC, or the actor template VDC, which in turn takes two parameters, like a client, an environment parameter, which typically includes the credentials to connect to the system, and typically a virtual data center can be installed on, in multiple physical locations, depending on the G8 environment. So I'll give you examples of this on how this works. And then I say, you know what, this own cloud thing needs to have two disks of 1 terabyte. Yeah? And it needs to be accessible through a host prefix my own cloud. And just install it. And you know what? And this is a real example. And we have it in the system. This typically leads for you to a web application, a Dropbox-like web application that looks nice, that is working, that is self-healing, because apart from these things that the system needs to know in order to do the actual provisioning, a template also includes all information for making sure that this application can nicely run. And think of it like, you know what, if the MariaDB, for instance, runs on a specific container, and the host of that container, meaning the 0S node, goes down or is about to be overloaded, well, the actor template code that has been conceived to not just deploy this own cloud instance, but to manage and monitor the instance, will have to include code to see that happening and to take measures to, for instance, move the workload to another container. And basically by interacting, among other things, but most importantly, with the orchestrator API. So that's the big logic behind all this. And okay, good. This is a summary of what I've been explaining a little bit. It's a full lifecycle management system, inclusive self-healing and self-scaling, mixes workloads, virtual machine, Docker Connect, whatever, deploys across multiple G8 grids. Well, think of it that when we talk about G8 and grids, think about clusters. Think about 0S clusters. The idea is that an at your service, even while we have been using it as part of a single cluster, you typically will also have other instances, remember my slides about that, other instances of at your service, under other AYS servers running elsewhere, that in turn interact with the 0S, the orchestrator, multiple orchestrators, so interacting with multiple clusters, and each cluster, each orchestrator in turn will have his own internal AYS doing exactly the same thing. So AYS can be there at multiple levels. Good. I think I have in my slide, so this is another example. I used this already before. This is an example of deploying an S3 server for 1 terabyte. And there you see again what we call the services that get created based on the definition included in the blueprint. And this will typically lead to, and this is a real example, to the creation of multiple things that at the end of the day are required. In this case, 2 Docker containers running on a single host. It includes some port forwards, and basically it's about 2 Docker containers that are being used here. It's a pretty simple solution, but even while it is pretty simple to visualize, still things can go wrong. The node could go wrong, disks could fill up, there could be network issues, there could be all kinds of issues, and the idea again is that the code included in the template should be conceived in that way that it can see all that and can restore the problem. So it's not only about provisioning or auto-scaling, but it's also about self-healing. Yeah? Good. Well, I'll do a demo in a minute. So what you already see on the screen here, this is an example of a blueprint. We see examples of blueprints. This is a screenshot of what you see in the cockpit. And remember, cockpit is the name we typically use as another name to AYS portal. So it's a view on the portal. It's an old screenshot, and because the new one will show the dependency tree more visually. And this is not showing really the dependency tree, but this is really showing like when he goes through the steps, for instance, to install, in this case, the S3 server, he shows that he is doing that in steps that are independent of each other. And then here you see another example of the application. This is the cockpit APR, or what we call the AYS API console. I will show it to you too. This is another. This is basically the one that I was talking about before. It's the old screen that shows all the services, but it doesn't show the dependencies. It doesn't show the hierarchy. The hierarchy is what you see here, but that's something I created myself, line by line. So it took me quite some time. But this kind of visuals will be coming into the portal later, will be auto-generated to make it all more visual. Huh? Okay, I'm not going to go through all the other slides here. Before I go to the actual demo, let me see whether there are still some things to explain. Maybe this, I always like to explain that a little bit. I like to explain from where the idea comes of actors or AYS. And I have another metaphor I've created here. Like if you want to do a business trip, you typically, if you have one, you talk to an assistant, or you could do it yourself. The assistant then typically will need to talk to one or maybe better more travel agents. And each travel agent then will talk to an airfare agent, two airfare agents, an hotel reservation, maybe we'll check for a car. And these two will do that independently of each other. And they might talk to other airfare agents and other hotels. And at the end, they come up with an offer to the assistant. And it's up to the assistant to decide which of the two is the most interesting one. And that's the idea that's where the word actor comes from. It's something that, well, that you'll find much information, a lot of information on this on Wikipedia. It's the actor metaphor is like what is being used in artificial intelligence or in the creation of basically distributed applications where multiple things work together and where they shouldn't be too dependent of each other. So if this one is not answering, no issue, this one will answer. And if this only receives answer for there is like a system where everything talks to each other through simple messages. And where the system should be redundant and intelligent enough to know what to do when messages don't come in time or when wrong information is being provided. The system should always be able to find a way to solve the problem. And this is just, well, then what I created to explain a little bit the metaphor. Again, to the left you see the concept of a template. No, sorry, the concept of a blueprint. As I already explained to you, it's always like the name of the actor template or the name of the template. Remember, we had an example with VDC here. And then underscore, the instance name. We'll show examples that we already have been using. And then you specify values. I could have lists of values. And at your service, the engine, the server, translates that in a dependency tree, where he knows, well, we tend to use the word actor, but think of it like the services you have seen them. Typically, we don't talk about actors in the way we visualize it here. You typically talk about a service 3, a service 2, and so on. And that's what is being shown here. Good? Good. For the rest, I have all kinds of slides explaining the concept of a cockpit. But I should not explain all that. A demo. That's the demo. I'll basically show everything to you. Good? Voila. Let's go back to my other slide deck. What I will first do to make it very understandable for you is this. I've prepared a little bit on this. So it's always nice to see at your service from the perspective of what you have been doing already until now. You might be aware, and probably you are, because I stressed it many times, when you were installing a cluster, and basically when you were installing an orchestrator, you had to use at your service from the command line, as you might remember, in the Docker container we have been creating for that. And we mainly focused on two blueprints, on creating two AYS services. The first one was the configuration service, and the other one was the bootstrap service. Remember that the configuration service was a pretty passive service. The only thing it did is hold configuration information. It's if you would go back to my previous slides, it's an example of a service that isn't monitoring anything at all, isn't doing anything at all itself, but it's typically a service that is available for other services to get information. So, and as you might remember, the configuration service, what did it hold as information? Information such as, you know what, if a container tries to, no, not a container, but if a node tries to join my management network, my zero-tier management network, I require that the version of ZeroS running on it is, for instance, Alpha 5. If it's not running Alpha 5, I'm not going to accept the join request from that zero-tier, from that ZeroS node. That was one of the examples that was in it. Other examples, you might remember, I'll show it, that the configuration service also holds information about the F-lists he needs, for instance, when people are going to create a gateway, or when they are going to create a cluster, or when they are going to create, Open vSwitch, something I'll cover a little bit today too. That's the kind of information it holds, and it's then the other services that will talk to the configuration service to know what to do. The bootstrap service was the more active service. That was the service that we have running that typically does do the actual installation, does talk to AYS to launch other services. The network service, we haven't been discussing it a lot. We have touched it a little bit the last time. I'll show it a little bit more today, but that's the one that we only introduced explicitly in the last session, I think, when we were explaining that you always have a physical network. And that this physical network, in our case, for the G8 environment, it was a VLAN that was set up through the switch. But of course, the physical network interfaces of the nodes, they need to know how to, let's say, bridge the physical network traffic to the gateways and to the to the gateways basically. And what we didn't show and didn't say explicitly, but it was said yesterday, I think. On each node, you will end up with an instance, a container again, that runs Open vSwitch. It's actually the network service who is responsible for doing that. He knows what to do in order to set this up. And then, and I will show it in the demo, once you have your orchestrator installed, once you have your cluster up and running, you get things done through the RESTful API of the orchestrator. Now, we have seen many examples of that. We typically have been creating containers, virtual machines, vDisks, and all the things on the slide. But what actually happens when we were doing that, it's very nice, is that we actually created services. And that we were not only, that's really important to understand, we were not only, for instance, in order for the gateway to come up, we did not only just create a gateway container on a specific node, but we also created a service, an AYS service. And to put it more correctly, what we were actually doing when talking to the RESTful API was creating a gateway service. And it was the gateway service in turn that would then actually create the container running the gateway software. That's important to understand. When talking to the RESTful API of the orchestrator then talks to AYS saying, you know what, this is what I want. And by saying, like, this is what I want, the AYS server will instantiate then a service, an AYS service representing the workload or whatever, in this case, for instance, a gateway, that needs to be started. And it's then this AYS service that will do the actual provisioning and, most importantly, make sure that this thing stays up and running forever. Okay. I've been working on the slides, clearly not complete, but here you have a screenshot of something you will recognize. In order to start a configuration service, you had to provide, remember, an order, a recipe, not a recipe, but an order, or in this case, a blueprint to AYS. So it's actually, when installing it, and I'll do it with other examples, you send it to RESTful API, to the AYS server, or simply by the AYS command line tool, which we actually used. If you check the setup documentation of the orchestrator, you will remember that we used the comment at some point in time, like create the blueprint. This was the blueprint you had to create. And then we had to launch two commands. The first one was AYS blueprint, saying, voila, this is a blueprint, check it out, execute it, and make sure that the AYS service, in this case, a configuration service, we call main, whatever, you can give it any name, and the main service is running. And then we had to execute another command, which was AYS run create. We'll do it again during the demos, which will then actually say to AYS server, check all the services and check whether they have actions defined. No, this one doesn't have any action definition, so this will not do anything. But remember, in the Bootstrap example, there was, and let's see it, in the Bootstrap example, this blueprint, it also did include an actions entry, more specifically one action saying install, meaning that after you have been saying at your service blueprint, which will simply execute the blueprint and create a grid 1 or an AYS service with a grid 1 name, which doesn't do anything, but only when you also say, no, at your service, please do a run, or we say that by doing at your service, run create, he will check all the running services. So grid 1 is one of them then, and he will see, there is an action defined for it. We need now to execute on it. And this action is then, that's, of course, there is code that I will show you that is being used. This one, by the way, we didn't cover too much, and this is certainly one of the topics we'll come back on later, because, well, you need more information on that, clearly. In the setup documentation, you will see nicely covered that you can set up a storage network. So next to the management network, the zero-tier management network, in order to have a very fast system, you typically set up a gigabit storage network interconnecting the nodes, specifically for the storage. That's also why we call it storage. Network.0s is basically the name of the template, yeah? And storage is whatever name you give to the network you are about to set up. You might remember of the session of yesterday that even for the cluster we did set up in VirtualBox, we did use the same blueprint, including the name storage. While in that context, it doesn't mean anything at all. And it will not make the cluster faster because we created an extra storage network. So it was a bit strange to call it storage, but anyway, it's just a name. And then you specify like a VLAN tag and the CIDR notation of the IP range that is being provided or that is being covered by this VLAN. And it doesn't say much, of course, but what you tip, and I will show you, if you check then the template, the code that is behind this template will typically do a lot of magic. In this case, what it will do, it will start up on every single node a container which includes an instance of Open vSwitch, which basically will bridge the VLAN on the physical network and make it available to the gateways that need it. And remember, the gateways that need it, then they had to specify through VLAN tag and ID 101 then, in order to say, okay, connect to the Open vSwitch on the node which was created by this. Someday I will create a picture of this to visualize it much better than we do now. Well, we don't. Okay, what you also see here is that in the Bootstrap service, again, there is also this entry networks storage, and this is just a way to make sure that this grid 1 service, yeah, knows about the network definition we have specified in the other blueprint, or more specifically, doesn't just know about the network configuration, but knows to which other service to talk in order to know what to do when storage actions are needed. Let's put it like that. Huh? Okay, this is an example of the container, but I never did show it to you. I will do it now. Huh? This is where we start the demo. So what I will do, just as yesterday, I have 3 tabs. Well, yesterday I only had 2 tabs to start with. The first 2 are the same. The first one is connecting to my, is basically connecting to my local machine where I'm running a Docker container with JumpScale installed and the orchestrator installed. So the same story as before. This is this one. And let me first do this because we'll need it. So what I will typically do there, I'll create an AYS token again because we'll be needing it. Voila. In order to talk to this AYS server running locally. Okay, that's one thing. Then we also have the other system. Let me show it to you. This is the other system. Also there, let me do the same AYS generate token. In this case, yes. Voila. So that the system is ready to receive comments. So that's something we don't have to lose time with it. Yeah. And I have a third one. And the third one is basically is not running any orchestrator. This is basically another Docker container running on another G8 even, yet another G8. And this Docker container only has the AYS service running. As you see, it's also running a MongoDB and some portal stuff that I will show you in a minute. It's there. The portal, by the way, is the AYS portal that you never saw until now. I will show it to you in a minute. The reason why I've involving another one here is that I want to visualize very clearly that you typically have an AYS service that is being used internally, let's say, in the cluster by the orchestrator, and typically you do not expose the REST API of the internal AYS server to the public, but the public or whomever who wants to can host its own AYS server because he likes the idea of this self-healing and self-managing thing. And this AYS service can also receive blueprints and will use these blueprints to know how to talk, in this case, then to the orchestrator. So it's like, I created that picture in one of my previous slide decks, where you typically have an AYS server, another instance, that is there to serve, for instance, a marketplace. For instance, the e-portal was a nice example. This AYS service talks to one, and typically only one in the demos, but typically have multiple orchestrators, and each orchestrator typically has only one internal AYS to get things done. Good. What I will do here, I will be showing you first examples of what you can do, not involving any 0S thing, just to make sure you understand the concepts. And at these levels, I'll show you exactly what happens. So let's have a look first, the simplest one, on my local machine. So on my local machine, there is this directory, and I have a slide on that for you as a reference, where you typically create repositories. And we'll see a demo later on creating these repositories manually yourself. But here, a repository already got created, and on this system, there is only one repository. In this repository, there is some file structure, and you see there is a directory with blueprints. And if you do a directory, if you list what is in that directory, what you will see is basically a list of blueprints. And that's where it becomes interesting, because what you discover by doing so is that the bootstrap blueprint is nicely there. The configuration blueprint is nicely there because we created it. We did do that manually. Remember, as part of the installation, you had to create, well, not the bootstrap blueprint, because that was created by the setup script, but you had to create a configuration blueprint. The other one was created for you automatically, but you still had to execute it. Now, what you also now discover is apparently some other blueprints got here implicitly or automatically or created by the system. Well, by the system meaning, remember when we were installing, for instance, a container, we were doing that by talking to the RESTful API of the orchestrator. What actually happened behind the scenes is that the orchestrator would talk to AYS by sending a blueprint. And this blueprint would then be interpreted by AYS to know what to do. Yeah. Now, and you see here, I have a blueprint apparently to create a container, install it. There is even a blueprint to uninstall a gateway and to install a gateway, to stop a container. It's a blueprint. So let's just have a look in it. Or let's take a gateway. That's something you will recognize as one of the first things you have used. Copy it. So if you do vim, like blueprints, and then the name of the gateway blueprint. Oops. Let's take another one. Not sure what I did wrong. Okay, I forgot the underscore. By the way, the underscore has a meaning. The reason why we use underscores That's typically to let the system know that he should disregard this order. It's like when you go to a restaurant and they take up your order on a piece of paper, and then it got into the system. The piece of paper can be thrown away. And the same concept is here. Once a blueprint has been executed, there is basically no reason to keep track of the blueprints, because once they got executed, the service gets created. And the idea without your service, I'll come back to that, is everything you do in an AYS environment, especially once you create a service, gets tracked through a Git server. So every change is being shown, and you can see who was responsible for that. So the actual note that came in saying what needs to happen typically can be thrown away. That's the idea. Yeah? So here you see it. Here you see, let's start here. We are defining a gateway 1. Yeah, and the first word before the double underscore specifies that we are talking about a gateway and that it needs to use the gateway template for that. And we create this gateway. We say, you know what, create it on node 1, domain, whatever we specified. And this is basically the example of yesterday. Yeah? We created a default network, nothing special, just a NAT to in this case, the virtual box network. Yeah? And then we did specify a private VXLAN with the host names. Remember, you recognize this. It's in a way a very much more easy to read representation of what we passed through the JSON body sent through the REST API. So here you have actually a YAML representation, which is much easier to read, of the JSON workload that we had to pass through the RESTful API. See? So it's pretty straightforward. That's how it works. Huh? And the same thing can be said about all the others. If you go, for instance, to the other system here, which of course it's a much more a bigger system, which is used by many things. If you would do an AYS service list, you'd see much more over there. So it's a full list of all kinds of things. So remember that at some point in time we have created boot disks. And this is the one we created yesterday. The boot disk was created. At some point in time we created a VM. We have been creating many VMs. And again, the same thing is here. When I take, so by the way, I might have been a little bit quick, because what I didn't show you is that here, before I did do this blueprint, list me all the blueprints like this, and I want it in one column. Yeah. Blueprints, is it, right? You see then the blueprints, the files, but the same thing can be shown by doing AYS service, and that's a logic, and then you can do help to see what can I do with the service. You can do all kinds of things. In my case, I'm just listing all the services. And clearly, each of these services maps to a blueprint. But remember, it's not because the blueprint exists that the service will exist. The service will only come to exist once you executed a blueprint. We'll show that in a small demo in a minute. Huh? So here you see a lot more of all kinds of things we have been creating, like let's take the VM. I was making a mistake by copying this, but this will not work, of course. What I need to do, again, is list all blueprints that start, in this case, again, with a VM, I think, like this. Well, star. See? A lot of VMs have been created and deleted. So let's take, well, anyone. So let's take this one, huh? Just as an example. So I do vim and the blueprint, and you see this is a blueprint. And again, you could put actions anywhere. Typically, this example always puts actions on top. And this is a more specific action that say, you know what? The action that comes with this order is that you need to install a VM, yeah? Actor or template VM. Which VM? Well, VM2. And force means false. So don't force things. If it's already running, don't restart it and stuff like that. And here you have the definition of VM2, which is a VM. That's the name of the template. That's the name of the instance. You say that's the node, the identification of the physical 0S node, That's the amount of memory, number of virtual CPU cores. And again, you see the VXLAN definition of this VM, yeah? The MAC address, and indeed the DHCP server that is active there will know what to do, and that's being specified by the ID. ID referring to the VXLAN ID that you have specified. And disks, and we have never discussed that, but I think in my example I do so. You can do all kinds of sophisticated things, like even specifying, like, you know what, all the disks, make sure they only that they are blocked on 2000 IOPS per second, input-output operations per second. You can really specify that. And here you say the vdisk ID was the boot disk we have been creating already before, for which already also a server should have been created. So let's do some examples to make it easier still for you to understand. In order to start examples, what I will do is not talk about ZeroOS. What I will do is I'll talk to OpenV Cloud. And remember, I should include that slide again in the slide deck. Talking to OpenV Cloud, or OVC, and talking to the orchestrator is in a way not the same thing, but it's equivalent. So in the current installations with our current customers, you typically talk to the API exposed by OpenV Cloud to get things done. Yeah. And that's what I will show you now. It's the equivalent of talking to the orchestrator API. Yeah? Okay, so let me show you that. So let me show you that like by this. So let's go to this system here. Let's go, let me explain what you see. Let's go to this environment. So I already shown you this in screenshots. This is OpenV Cloud, more specifically, this is the OpenV Cloud Operators Portal, more specifically even the Cloud Broker Portal. And in the Cloud Broker Portal, you can do all kinds of things. And remember that what I said, later in August, in one of the next sessions, we will be showing you to use all this on top of a ZeroOS cluster. That's the idea, that all this you see here should work as well on a ZeroOS cluster. But let me show you, I've created an account here, and an account is basically the equivalent of what you, at Microsoft they call it a tenant. It's a tenant, you create a tenant. In my case, I've created a tenant with the name Account of Eve. And in the Account of Eve, you see I have a cloud space or multiple cloud spaces. A lot of them are destroyed, so let me filter on deployed. Yeah. Then you'll see only the ones that are actually running. So you see cloud spaces. Cloud space is just another name for a virtual data center. A virtual data center. And a virtual data center is basically the same thing as what we showed you with the VXLAN. Remember the VXLAN? And you could only create a VXLAN by creating a gateway. So in a way, a cloud space or a virtual data center and a gateway is almost the same thing. They represent the same thing. They all represent a VXLAN. Yeah? On this VXLAN, well, on this account, the Account of Eve, in this environment, I've created three gateways, let's say, or 3 VXLANs. Not important why. And what I will do as part of the demo, I will create one from scratch. What I will create, let me show you, if you click on it, on this one, we can click on it. This is a VDC test, and this is again a VXLAN cloud space and a virtual data center with some configuration. We'll not discuss that too much today. With some access definitions, with some port forwards, and the actual virtual machine. And here then I have a virtual machine. I can click on it, and also at the virtual machine level, you all have all kinds of settings. See, all kinds of settings, an audit trace of everything that happens there. In a way, it's nice to see this. It's just a very straightforward representation, visual representation of things you will recognize of what you would typically deploy to the orchestrator API. And it's just an example of how you could visualize this, because all this is just a way of using the RESTful API. You could perfectly create your own client. And why not? As you already discovered, I like things like Atom a lot. Right? Atom, what is Atom? This is Atom, by the way. And I like a lot the Insomnia client. What do they have in common, by the way? They both, and just like Visual Tools, the Microsoft thing, they all have been created using Electron. So it would be a very nice project, I believe, to have somebody create an Electron version of the client, visualizing everything in the system. That's certainly one of my wishes. One day, maybe you can do it, I don't know. Anyway, so here you see what I try to achieve. So let's go up 2 levels. Let's go back to the account level. And let's go back to this VDC, like this. And let's just delete it. Let's delete this cloud space, including everything which is underneath it. So clean up like this. Have it deleted. And let's really start from scratch. And by the way, this is nice to show you. The equivalent of the orchestrator APIs, I'll show them right now for you. In the OpenV Cloud, you have under System API, and there you have all the APIs. For instance, you have a set of APIs. We'll only discuss the Cloud API. The Cloud API, here you have it, is like this. You have a Cloud API for managing accounts. You have a Cloud API for managing VXLANs or cloud spaces, gateways, yeah? And you have one for managing machines, like adding disks, creating virtual machines. Very nice. And I typically do a demo like, let's create one, because these are not just like, these are really interactive. So what I could do on accounts level, to take one, is list, for instance, all my accounts. And this doesn't take any argument. He sees that I'm logged in as a administrative user, and he will now list all the accounts I have access to. And basically what you get back is JSON, JSON with all the accounts. Clearly my own account of Eve, I have access to my own account. Maybe somebody else gave me access to his account too, I don't know, yeah, so on. Account of Gary, I also have, as it shows to be, I also have admin rights at his account too, right? So this is the ID. It's very nice. It's an API. It's really easy to use and to understand. It doesn't come with any documentation simply because it's so self-explanatory. So creating a virtual machine is really simple. Let me show you. You go to, not add disk, but you go to like create a machine, and it takes parameters. Which one? It needs to know the cloud space. It needs to know the name. It needs some description. The size ID, I'm not going to discuss it, but size ID typically combination of number of virtual CPU cores, memory, and the supported boot disk sizes. So we have another set of a table, let's say, that lists all the size IDs, and then you can specify of them. Image is like the boot disk image. The disk size is the boot disk size, and that's all you need. You could also list a list of data disk. You try it out, and basically the virtual machine gets created, and it works. You can play with it. Typically, of course, you need to look up the cloud space ID. How do you do that? You go to cloud spaces, you list your cloud spaces, and for instance, the account of Eve, for instance, no, not account of Eve, but the one, well, it's somewhere there because I have a long list here, is somewhere there. By the way, the other way to find out, you simply go to like this, cloud spaces. You look for Eve in my case, not this one. Well, I could use this one, and that's the ID. So you then take this ID, the 141, and you basically create a virtual machine. Or instead of try to play with it once you got access from me, it's very simple. What I will do, I'm not going to talk to the orchestrator, not to the OpenV Cloud API. I could now exactly do the same thing. I could start doing this and talk with it and get things done. It would work. You would recognize that it's almost the same concept as what we have been doing with Orchestrator. Yeah? Now, what I will do is talk to a layer on top of that, talk to an AYS service. Another AYS service, not the internal one being used internally by the cluster, but another one that is there just to represent like an API wall against another layer of security also against this API. Now, how do you do that? First of all, I've included the links in the slides. It's already rather nicely documented. If you go to Jumpscale AYS, there is a directory docs. Yeah, all these files need to be updated by myself. But what is up to date all there is the section how to and the getting started. So the getting started explains you what you typically need to do on a Jumpscale 9 Docker container, as you all learned how to set it up. And remember, as I said in my last session, today we are on 9.1.0. So if you set up a Docker container, Jumpscale development Docker container 9.1.0, you can do all these like start AYS, join the zero-tier network, which typically is done for you by installing the orchestrator, install the Python client, that is something you typically do on another system, not really necessary, and start the AYS portal. We didn't do that yet today, or in the other sessions, but I will show you today. Yeah? More interesting is that you go to the how-to section. The how-to section is here, and the how-to section lists you all kind of, gives you all kinds of tutorials on how to do many things. Like the one we will be using is creating a virtual machine. So how to create a virtual machine. And here you see the full documentation of how to create a virtual machine. It gives you a minimal blueprint. It shows you a full blueprint. You could hand a lot of information in the blueprint. It shows you an example, and that's actually the example I'm about to use. Yeah? It explains you all the values that you can pass, how it works. And then I have several examples of how to use. I use the AYS command line tool, so I show how to do it from the command line, and that's what I will be doing. And yeah, what I just discovered, that here I'm not finished yet, but if you, for instance, check, for instance, how to create a VDC, and there you see that I even have more things that I not only explain how to do it from the command line tool. So I really invite you to play with this, learn or try to explain it at least. But I also explain, for instance, a lot of details about AYS, how it works. And also explain that you could also talk to the RESTful API, I'll show it to you, of AYS. So also AYS has a RESTful API. I'll come back to that. So the orchestrator, equivalent of, let's say, Open vCloud, exposes its functionality to RESTful API. The AYS service or services talk to that RESTful API, but they're part of a server that exposes its functionality in turn also by its own RESTful API. And you know what? The command line tool basically is talking to that API. It's not the other way around. The command line tool is basically a client of the RESTful API of the AYS server. Yeah? It explains you every single detail of what you can do, even on the command line. For those that like to do REST calls from the command line, I've really made sure that it's nicely documented. Why did I do it like that? It's the most neutral way of documenting stuff. Showing how to use the curl command that you could perfectly also use from Windows in order to send over, in this case, as you can see, this one is one for creating a repository. It's containing the full JSON workload, as you saw yesterday, for the other things. There is also a Python client for the Python programs. You also have a Go client that shows you how you can do this from code. And this is quite relevant because this is basically the code that you will be using in your template. This kind of code is what you will be using in your template in order to talk to the AYS service. The AYS service, talking to the AYS server from the final client application, customer application. Okay, so let's get started. So what I will do here, so I'm not talking to 0S, I'm not talking to orchestrator, I'm talking now to the AYS representing an Open vCloud environment. Yeah. Now, what I will do, let me go back to CD opt_var, just like what we did in the case of the orchestrator environment running in the Docker container, the same Docker container here that we are using, the same image. And there you'll first of all see that we can list all the, we can ls, simply ls. And what you see here is a bunch of directories. See, a bunch of directories. and each directory represents a repository. Now let me show you how it works, and let me also explain what a repository is. First of all, a repository is like a boundary of reality. So within at your service, you typically create repositories, and they are really separated from each other. Typically, a repository represents a customer or one guy testing stuff, and he doesn't want that the services he's creating are visible for other customers that are using other repositories. So it's really a boundary of security, but also internally in the system. You cannot have a service talking from one repository to another repository. That's not how it works. The repository is really like, that's where it needs to happen. So if you want to have things talking to each other, you need to have them both created as a service in the same repository. So what I will do first, there are multiple ways of doing that, and I also have documented that in the slides. I've started at least with that. So when creating an when creating, let me check. Yeah, it's not yet really in the slides, but I'll come back on that. What I first need to do, I'm here. The first thing I need to do, of course, is just as before. In order to talk AYS, I need a JWT. Remember? So let's go back to this command. So AYS generate. Yeah. And here again, I use some client IC and some secrets, just as before. And typically, let me learn your trick if you don't know. Instead of doing the export, do this like this, eval, and then he executes it at once. Voila. Good. And again, what I can do now, I can go to a repository, go to an existing repository like eve01, because I have one eve01 here. Let's go to that, like this. And then you can do AYS service. And by the way, the first thing you do is AYS help. Then you see everything you can talk to. You can talk to about the repository itself. We'll be showing it. You can check the services. You can check the blueprints. You check many things. So in our case, I do AYS service. And then again, I do help. We did do well again before. And I list everything. And then you see whatever service got created. You see there is a service for representing the account, a service representing a disk, and other stuff. See, that's what I actually will be doing. Now, in order to create a repository, let's use the command line tool. There are multiple ways of doing that, all documented. And again, where is it documented? It's documented here. You go to how-to, you go to the how-to section, higher, like this, and there you go to how to create a repository. And that's what I meant. You can create a repository through the command line tool. You can do it through the RESTful API, the Python client, the Jumpscale client, at your service portal. And I'll show most of them to you in a minute, right? Okay, so let's start with the command line tool. So AYS repo, create, and then you need to specify a name. And again, if you don't know, you do like this, help. Okay, what was it again? Okay, I need to specify a name like this. So name. Let's call it eve03. And then we need to specify Git repository. A Git repository could be GitHub or any other Git server, your private Git server or whatever other Git compliant server. You need to specify a URL. Typically for demo purpose, I put whatever. It needs to be something, but in reality, you will specify an existing repository somewhere at GitHub, for instance, so that you are sure that everything that happens in that repository is getting synced up and even can provide you some workflow and so on. Voila. Now, as a result of that, what happened? And it takes a long time, it shouldn't. What is happening? Let me show you something else. It should not take long, but should already have been doing a long time ago. But what I want to show you is the AYS portal, or the cockpit. And just why I'm showing you this, because there you see a more visual representation of the repositories. And here you see it. Here you see the repositories in this cockpit. So normally if I do Eve, I see the two that already got created. In the meantime, Evo3 got created, see? So if I check again here, like refresh, Evo3 should be there. Yeah. not like this, like this. Evo3 is there, I can click it, and in this repository, I can see some information. Huh? Now this is the same thing, if I do cd ev03, I see indeed some empty stuff. Now there is nothing in blueprints because I didn't create anything. Huh? It's empty. Now I could create my blueprint through this thing here. I can create my blueprint like this, blah, 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 and then some parameters, and then apply, and it would work perfectly. Huh? That's one way of doing it. Huh? Feel free to use it like this. You give it the name, you apply it, it works. Huh? Now, what I will do, I've prepared a small demo. Well, no hocus pocus here. The only thing I did, I got to the documentation, and in the documentation there is this example how to create a VM. And the reason why I'm showing it again is because there's an error in the documentation I need to fix. I took the example. This is the example I'm about to use. Yeah? But there is a small error in the script. And let me show it you here, because then you understand. This is the error. Why is this wrong? Well, let me explain. This is basically the definition, the actual definition of the VM that I'm going to create. So I'm specifying, this is the name of the VM that I want to create. And this is the name of the template that includes all the code, all the logic needed for Azure Service to create a VM, but also to monitor the VM. Yeah. Now the error is here, so I specify the name, and then I say, you know what? This VM should be attached to the VXLAN with this name, my VDC. The problem is that when he checks the rest of the blueprint, he never sees any MVDC, my VDC. He doesn't see it. There is not any definition for my VDC. Now, what Azure Service typically will do in that case, he will just create one from scratch. Now, that doesn't work because he still needs information which is not supplied anywhere in the repository. So that will clearly fail. Now, what needs that to be? This needs to be this name, VDC test 1, because I need to refer to this definition. And VD test 1 then says, you know what? In order to create it, talk to this system, yeah? And in that system, you need that location. This system is defined here, and it's basically the URL of the system that I will show you, that I was demonstrating. That's basically this one. So BG1 is this system. So it's talking to this system. And by the way, in that system, I created an API user, just so that you understand. I created an API user, this user, yeah? And this API user, it's an API user. Let's go back to the documentation so you see. This API user that you specify here, you specify the password, and then you specify the account or the tenant in which everything needs to happen. In which, first of all, the VDC gets created, in which the VM gets created. It's also referring to a bunch of disks, the my disk 1, and my disk 1 is defined here. It's a 500 gigabyte disk, it's a data disk, and it's only accepting IOPS until 2000, let's say, and here you see the image. So it's quite straightforward. There's nothing difficult about all this to do so. So what I will do, let me show you. What I will do is take the example, and how can I make myself the life as easy as possible? Well, the easiest way is go back to the command line, yeah? And let me just go to the repository I've been using for my preparation. And what I do is vim blueprints, VM, YAML. Let's open it. Well, no, let's do it differently. Let's close it again. Let's just copy this blueprint VM YAML to the other repository that I just created, ev3. And put it there in the same blueprints directory and also call it VM YAML. Now, if I go back to my repository that I just created, it's there now. So if I go to Eve Blueprints, it's there. See, it's there. And also when I go to the AYS portal, aka cockpit, and you go to Blueprints, you should see that the new blueprint is there. See, that's the one. Oh, Yeah, okay. They changed something. I was. This is ugly. It was better in the previous version. The coloring is gone away. Now here you see my API stuff. I need to make sure that I delete that. Okay, so it's there. What I will do now, I prefer to do everything from a command line tool. First of all, and that's maybe a bug. Let me check whether it works. If I go to this repository at this level and I go to services, you see there is nothing. There is no services. Remember, also here when I do other service service list, what you will see, there is nothing. There is no service. Because simply, I only specified the service, the definition. It didn't create anything. So when I do now at your service blueprint, that's the way you do it. And you have two options. In this case, this would be enough because I only have one blueprint, but I could specify very specifically like blueprints and specify the name of the blueprint. So here I'm saying, check the blueprint and make sure that service gets created like this. Huh? Yeah, of course. You should know that in order to make that work, don't include the directory blueprints, just like that. Okay? What happens as a result? He's doing all kinds of stuff. He's creating the services. Huh? You see that happening here? He's creating the services. So we're going to do at your service service list. You'll see he got them created. Or, and let me check because I got an error there in this version. Yeah. So this is an error that we still need to solve. Don't bother. But here you would see, and that's a pity because here you would see not just the list, but you would see a nice hierarchy of the services. You would see like how they depend on each other. So it's a pity that I can show you that, and that was one of the things I was still trying to get fixed before we started. But there is always something that needs some follow up. Okay, now realize once again that nothing really happened. AYS has a bunch of services running, but they are doing nothing. They are there waiting for me to say, and now, please, AYS services, do your thing. In this case, actually deploying stuff. Because when I go again to the system we are talking to, this system, this system I mean, and we go to the cloud spaces, or we go to the account, let's do it like that, I'll rather do it like that so that you understand. We go to my account because that's the account I specified in my blueprint. You will see that the VDC that I'm about to delete already exists. Well, existed. It's destroyed. See, so it's not there anymore. So I destroyed it. So if I would look for destroyed here, like this, and there is this VDC test one. You see, I've been doing some tests as a preparation, but they are all destroyed. So I'm fine. It's nice. So what I will do now, I'll do add your service, and then we say run. What is a run? It's maybe a strange name. A run is when you say to the system, go through all the services and check whether they have something to do. It's a run. You say run and get work from whomever of the service has work for you. Yeah. And you could do run list also, and then it shows you all the runs that are still busy. There is nothing running, really nothing running, so there's nothing to list. Again, you could do run help, so you see everything you can do there. This is quite useful, especially the show is an interesting one because it allows you to see details of what is actually happening, especially useful for long-running runs. If it's taking a lot of time, it's sometimes nice to see what is happening. What we will do is AYS run. We create one. Yeah, we create one. And there is a way to do it asynchronously and synchronously. The minus, I think, follow. In a way, it's nice to do it like that. The follow will do it synchronously, meaning you'll see the status on the screen while it's doing. So I say follow, and then you say, okay, that's what I see that I need to do as a work. I need to create all kinds of services, and I do it in a specific order because I cannot create, for instance, the nodes, as you can see here, if I don't have a VDC, and I cannot create a VDC if the account is not ready to do so. See? So he's doing it in steps, and it knows how to do it. So I say, yes, go ahead. And now he's actually doing it. So, and here you see where he is in the process. And here you see basically what is actually running at the back end. While all this is happening, what you will see, do a refresh again, is that at least the VDC test that I specified got created. So I go to Cloud Spaces, and there you see VDC test is getting deployed with this specific IP range. Have a look, there it is. And he is currently creating the VM. The VM is already running, so it's quite fast. And no port forwarding has been specified. I could have specified too. And I can go to the VM, and probably it's all done. It's still doing stuff there apparently, but as it shows here, everything is nicely running. I could even log into the system. There is a username and a password. There is an IP address. So what I typically will want to do, because just as before, it's active on a private network, yeah, on a private network, but it's not exposed to the public. So what I will do, I create a port forward like this, 7122, and I say on the machine take port 2, public access, voila, just a reason. Okay, confirm. So this is creating the port forward. By the way, this I could also have been doing the exact same thing through a blueprint. I could create a blueprint that would actually do that. And by the way, you might have seen it. Here, you see the audit trail of everything, in this case, happening on this virtual machine. So everything that the AYS service is doing goes through the same API. So everything is nicely monitored. So what you see here is that on this public IP address, I've forwarded this port to the port of the system, and this is then the VXLAN. So remember, that's 11 and 12 we used in the 0S examples, and this was on the public IP addresses, the 30 yesterday, and the 38 and 39 I used before. So what I can do now, very simple, just to prove that it's working, SSA cloud scalers like this, and then do this, the IP address, and the port was 7122, right? I say yes, okay, and then he'll ask me a password. This time he's asking me for a password, which was not the case in the demos of yesterday, simply because yesterday we used the Cloud Init, and in the Cloud Init we made sure that my public key got copied into the authorized keys file of the system. See? So what I'm showing you here is basically what you will be able to do when talking to a cluster OS through another AYS service, for instance, to deploy a virtual machine. You would basically, no, not just basically, you would perfectly use the same blueprint, the exact same blueprint would get translated into what happens. Now, how all this works, and before I do so, let me show you something else, just to make my point again. So here again, my beloved tool, Insomnia. And what I did here, so in Insomnia, remember, we used until now also this workspace, the 0S workspace. I created another workspace. It's still work in progress, the AYS workspace. And here I've been creating an environment Artilium, yeah? And in this environment Artilium, started by creating the same structure. I still have to do a lot of work, that allows me to create or to send blueprints and all the things that you typically need to do. So for instance, creating, and this is the example, let's take the list one, for instance. Won't work, of course, because it works. So I list all the blueprints. No, I list all the repositories. I could easily create a new repository like this. Let's call it let's create a for fake. Let's put fake now and send. So basically, I created a new repository. Just so you see, if you go back here to this machine, and you go here, and you do ls, you see E4 got created. And the same thing here at the level of AYS, you go to repositories, and E04 got created. See, it's just another way of talking to the system. And that's what I started to document a little bit in the slides. that it's all about this RESTful API. So I finished here with AYS RESTful API. So in Insomnia, yeah, this thing here. So here you see the UI of this. But in reality, this is the gate to everything. Just like the orchestrator is the gate to everything. You don't get things done elsewhere. You always need to talk to the RESTful API. Even in this case, the AYS command line tool, the Python client, all documented, the portal, they are all there. Now let me show you one more thing, because there is this AYS API portal, which is kind of interesting. So I show you the Insomnia, but we also have for Open vCloud, let me show you that. In the cockpit, if you go to the cockpit like this, this is the cockpit, remember? There is this, here API, AYS API, and this leads to the API console. And what it shows you is exactly the same API I've been using, like creating a repository like this, remember? That's what I did. I could now do, why not? Let me show you an example. I do like authorization, like this. Let me do one more thing. Let me go back here, just that you see something else. You can also generate a JWT like this. In the portal, there is a way to generate it. Like, let's do it like this, confirm. Copy it. Let's copy it. Copy. Voila. Go back to this here, to this one, and do like we did before, the mirror. Voila. So this one will create a new repository. Yeah. Of course. Well. Yeah. This is annoying. Let me show you how I can do that. So let's go to the. I'm trying something I didn't try. So let's copy this one, JSON. Just another way to do the same thing. Let's create the 5 like this. If everything goes right, I'm basically creating a new repository. See, it got created. And to prove it, you trust me, of course, it's there. See? So what I just showed you is that this API console, which is part of the cockpit, which is just another name for the AYS portal, is one of the ways for you to interact with the RESTful API. So it's all about the RESTful API. We have even let's say, a kind of Insomnia kind of client specifically conceived for interacting with the RESTful API. It's part of the AYS portal, let's say, aka cockpit. That's what we typically call the cockpit. Yeah. We also have the AYS command line tool. We didn't show it, but I showed you a little bit of it in the documentation. We have also Python client that shows you, that allows you from Python to interact with AYS. It's just a wrapper to sending the workloads, the JSONs, to basically to the RESTful API. Okay, good. Next, where are we? Let me check the slides, because now I need to check also with a colleague who was preparing something for me. In the slides, the only thing I did for your follow-up is some review. So you need to have a JWT. You already know the trick. Do this. Go to, not like this is like programmers. Go to the repositories directory. That's always where everything happens. So remember also, in the case of the orchestrator, it all happened there. And then create a new repository. You have been seeing doing me. Go to the repository, list all the blueprints, and you can list all this. That's what I did mainly. What I want to show you next, and let me go back to my colleague there and ask him to come with me, and also see that I need power, so I need to fetch my adapter. But what I want to do now, as a follow-up, 2 things. I'll show you the actual code behind all this. And that's where it becomes interesting, because that's actually the code that you will be writing. So give me like 30 seconds. Okay, I'm back. Here I am. with power. Okay. And let me show you a few things. So 2 things to finish them, basically. So I'll show you 2 directories. First of all, if you go to the JumpScale repository or the JumpScale Git organization, you have AYS 9. In the AYS 9, you have the directory templates. And in templates, there you'll find the templates. Yeah. Now, I'm going to show you 2 sets of templates. This is the first set of templates. This is a set of templates that we have been using, for instance, to create a virtual machine on top of OpenV Cloud. And that's as you see here, OpenV Cloud. And the one we used was the Nodes one. Nodes. You see that we even have templates for deploying a Docker machine, to deploy a packet.net machine on KVM. We have all kinds of templates. The one we used during our demo was the node.ovc. Remember, in the blueprint, it was node.ovc __ VM test1 or something. Yeah, click on it. And there you'll see basically the files which are important. It's always a little bit of documentation, but the code itself, first of all, the schema. Here you have all the parameters. Very, very technical, but that's what you saw also in the blueprint. And here's a code. And this is very simple code. And the one you will recognize install. Remember that when we said AYS run create, you basically say to AYS, go and check all the services, whether they have actions that have been scheduled to run. Yeah. And if you saw it, the install was scheduled by specified install actions install and so on. And then you would basically execute this code. Now this code, you know what it is? It's simply the code that I showed you of the API. So this is talking to this API here. No, this API. So this API is the equivalent of the orchestrator API, but in the context of OpenV Cloud. Yeah? And here you see then the code that will actually do the installation. So it's only then that the actual installation takes care. It's also here, and it's also here where you will be implementing all kinds of process changes and export of virtual machines. You will be adding monitoring disk features. It's really the place where you make Azure Service intelligent, where you make sure that Azure Service knows what to do in what situations. One of them, I don't think it's implemented here, is the monitor one that typically will be scheduled like to run like every 5 minutes, where it will actually monitor, is the VM still there? Can I still ping it, for instance? And if not, or I see that it's running out of memory, that, okay, let's spin off another one and create, why not, if it's a specific workload, a website, for instance, spin off a load balancer. That could be one of the actions that you do. You say you have 2 VMs, you see both of the VMs are low on memory, well, create another one and make sure that everything is fine. Or kill one of them because we don't need so many VMs. That's the kind of code. No, this is one of them. The other one, the other set is you go to 0OS, remember, on GitHub. In this case, we go to the orchestrator, yeah? And there again, you have templates, yeah? In the template directory, you should recognize a few things, yeah? As I showed you in my slides, one of the things that you see is like a container, or the easy one. Let's take the Bootstrap service. Where is it? Is it this one? Yeah, the Bootstrap service. Eh? And the schema, remember, is quite simple. So the ID, the token, the network, we didn't use much of it, but it's there. Or take the configuration one, the one which is quite passive. Remember, the schema was quite straightforward. It's only taking like a struct, a non-defined struct of configuration files, and in the actions, it basically holds all this information simply in memory, in a dictionary, for other servers to look it up. Yeah? But for instance, the more sophisticated ones are like the container. The container. The container also takes parameters. a lot of parameters specific to the working of a container. And again, there is code for doing the actual installation, for doing everything. Yeah? Now remember, and I should visualize that in the picture, this is a container template or an AYS service template to be used in the AYS server that is internal to the cluster. So this is basically the template that is being used by the AYS server that ZeroOS, that the orchestrator uses to run the infrastructure, right? Now, what I did in the meantime, I didn't do it, my friend next to me was doing that, is the following. On this machine, you see the third machine, so this is the local Docker machine that I used yesterday. This is the big machine. This is my local machine, the one I've been using for creating virtual machine on yet another environment. What I do there, I go to a directory opt code, I think, right? And there, is it? No.
I forgot the slash at the beginning.
Yeah, sure. Yeah. We go to opt code GitHub jump scale, right? And there you'll see all the repositories specific to jump scale. So this is the exact same thing that you will find on your environment. That are the repositories. The one we need to go to is the AYS 9 repository. Yeah, just to show you. So this is just to show you. This is basically then also having a directory templates. Yeah, right. I can list them, and there you see all the templates that this system knows how to work with. And you recognize the file structure like nodes, like OVC. Let's go to OVC. Let's check out that one. If you go to not here, but this one. If you go to nodes, no, templates, and then OVC. That's the same structure, see? OVC. And there you have like the VDC one, that's one we used. And here you see then again an example of what we actually have been doing. Now, before I go to the demo, the extra demo, there is also the, not here of course, because we don't have an orchestrator here, but for instance on this system, if you go to the opt code GitHub, well, you'll see an extra thing, yeah. You list everything. You'll see there is also a ZeroOS directory, and in the ZeroOS directory there is the Zero orchestrator. Just so you see, there is a template, yeah. So cd Zero orchestrator, and there is a template directory, right? And here you see the exact same directories you see here, right? But just make sure you understand that this is at the level of the orchestrator. Now, what we will do, we go back to this other system that I've just introduced today, and there I've Jonas created a new directory, demo, cd demo, yeah. In demo, you'll find let's say a hello world example of a blueprint for creating a container. Now, it might sound strange because we already have one. We already have such a thing at the level of the templates in the orchestrator. We already have a template for creating container. But this is the template that is being used internally. We could use the same one, but on purpose we are not using the same one, just to make a point that you could have other logic at the higher level, probably simpler things. You won't be, because this will happen internally, but at the higher level you might be specifically implementing a container for instance, deploying a MongoDB, for which you hand over a specific F list. And the real work is of course done at a lower level, at the level of the AYS service running in the AYS server within the cluster. Now this one, and I'll see it for the first time myself. I do vim actions. Well, maybe first let's check the schema. Let's check the schema. And you see it's a very simple one. It only takes 2 arguments. It wants me to specify the orchestrator API because it's very possible that I want to use this AYS server to talk to this orchestrator or to this orchestrator. It's up to me to decide at the level of the blueprint that I'm using here. And then I take only one parameter, a token, and the token is probably the JWT token I need to pass, which protects the API of the orchestrator. Just as what we always had to do. For the rest, what Jonas did do, let me show. He did basically hard code, just as an example, the actual thing that needs to happen, because there is no argument to say, oh, I want a container of this with this VXLAN. No. It's all hard coded. It's like a higher level. So I check now the actions. Yeah. And here you'll see the actual code. I'm not sure whether it's a lot of code, where you see the actual code. So here we see, we haven't been showing that a lot, but remember in the first sessions, we have been playing with the 0S client, the Python client, and we have been using it to interact with the nodes directly, talking to the Redis. What we never really have shown you is that we also have an orchestrator client as part of the same Python client that allows you to talk with all this. And the only thing we do here is, I'm not going to try to read the code, but we are basically connecting. We are connecting to the orchestrator. We are passing the JWT. We are listing all the nodes, and we are just taking, we are making sure there is at least one node, and we take simply the first node in the system. So if I would talk to this system, remember this one, it has 10 nodes, it would take node 0 basically. Yeah? And he would create a demo container with his name, specify some data, most importantly like the flist, some NIC configuration, which is simply hard-coded here, the hosting, blah, blah, the storage network that needs to be used for this. So he's going to fetch it. Anyway, this is the storage network be used by, from which the, let me think, from which the actual files come. So the flist doesn't define where he needs to watch. I know that this one, I think, doesn't need to be there. You can, it's optional. It's optional because there is a default value per node, but it's better to put it there. It's clear, no ambiguity. Then you create a container through the API, so it's all quite strange, all quite straightforward, and well, some error handling it's that. Yeah? So, and remember my slide where I said, you know what? What about state? Well, state is being handled here at this level, yeah, at this level, and at the level also of course of the AYS server running internally. You will also manage state. Yeah? Good. Now, how to test this?
We have to create a blueprint.
Yes. So what we do?
Test it, so we will see what it does.
Yeah, it will. Yeah, probably will fail, but that's the demo, and then we always have something to follow up. So we go to optvar, again the same cockpit directory. Yeah, but you need to cd, of course, like this, and there we do an AYS repo create. Remember, name demo. And we make a repository HTTP the universe loves us. It's really true. Like this, isn't this true? The universe loves us. Voila, he's creating a repository. It's there, so I go into it. I go to demo, right? And now I need to create a blueprint, right? So I do vim blueprints and I create a container. Let's call it C YAML, right? And well, what's the name of your
It's demo.
Demo. And by the way, let me check something. Demo underscore score, and we call it C1, like, and we had to pass what exactly?
The IP of the orchestrator.
So it's like IP?
Orchestrator IP.
Orchestrator IP,
Yes.
like this. And the IP, what is the IP? Well, there are many ways to check, but let's use, I forgot about it myself. So what I do is I take Insomnia and I go to, like yesterday, 0S. I go to manage environment, and for this system here, we take this IP address, right? Correct, huh? Yes. So this is IP address, and
it has to be between.
Okay.
It's a string, so it has to be between.
Yeah, it's a string, right? And then we need to, what was it again? The token. Huh? Token, chuck. How do we do that? Go back, not here, but let's do it here. Here, right? And what we do is simply do Control R AYS generate token. Yeah, this looks okay. Takes a long time. Okay, copy the string like this. Copy. Okay, and we put it here. Okay, this should be enough. Before I execute it and so on, this is okay. Yeah?
We have to do the actions still.
Actions. Let's do it in the same actions. Otherwise, nothing will really happen. It's like this. Huh?
Yep.
Action.
Action install.
Install.
And also specify the actor.
Is it necessary?
I don't think so though.
It's normally not necessary. I could specify actor and then specify demo if I want to. Yeah, I could even specify the name of the service, but I won't, because there's only one. Okay? All right. So this is okay. Before I actually do this, let me remind you that we have indeed a cockpit, also known as the AYS portal. And in the AYS portal, we should see our friend demo, like this, it's there. And in the demo, you should see the actor templates. And that's where I was wondering whether an extra action is necessary. Because demo, I don't see it here, but maybe, and there's is demo there? Let's check. Let me explain what I'm trying to do. It's not there, okay. And let me show you how you can fix that. I need to copy it from here. I've already been doing before, but I always forget. Voilà. Okay, so what we do now, we do AYS actor update, because this repository doesn't know yet about the new. And to be honest, I still wonder whether it not an extra action is necessary. I still wonder. Is it there?
Maybe you first have to execute the blueprint.
No. The template needs to get here too, huh? And because this repository doesn't know about it, this is not even. Wait. Let's check out the level of. Yeah, you cannot see it. Actor templates. Let's do it like that. Sorry. Let me check here first. Actor templates. Oops. Actor templates. At least we should see it here. So I would have expected to see it here. So I think we need to load them. Is there an action here? Update templates. Let me see that whether that helps. Confirm. Maybe this is not all necessary, but normally it would be necessary. So what he's doing now, he's checking for updates from its source and probably also from disk. So this takes a while and maybe it's normal. No expect errors occurred. Please try again later. This is certainly not what I expect. Is demo there? It's not there. Okay, this is for me strange. But anyhow, the next step normally would be now, again, AYS blueprint. And in this repository, again, I could specify the name of the blueprint, but it doesn't matter. So there is only one, so just do it. And now he is basically creating. You see, it doesn't find the demo. Template. So we need to, what I can do to force stuff, what I will do, have a look, Control B up, and I will simply close or halt the AYS and restart it, just to let it do. This takes a while. Voila, it's done. And we start it again like this. Okay. Not sure whether that would have helped now if I do a refresh here. Anyway, I would do a fetch on demo. Still confused, I don't see it. Oops. Actor templates. Okay. It's maybe a glitch because I probably also need to restart the portal. He's still doing that. AYS, everything is fine. Does it get better? Actor templates. Okay, that's something to check. Anyway, I still believe that it should work. Control B down again. Let's try once more. Well, the update maybe that is useful. This takes longer than before. Yeah, the same error. So that's something to figure out what is wrong here. Okay, this is strange. What is he showing me here? Huh?
I have no idea.
No, me neither. Yeah, it's a pity. There's something going wrong here. AYS blueprint. Yeah, not here, of course. Wait. I'm in the wrong repository all of a sudden. CD. Yeah, something got wrong, but I still hope that I can see it working. But there is clearly something wrong with failed to establish connection. I don't know what it is. Yeah, maybe it's because this thing is running on a 0S again. I don't know.
Yeah.
But
maybe we can copy the template to the other repo, to the orchestrator server repo.
That's what we could do, yes. So there is another thing that that is maybe a good idea. If you check the repository, there's also a private actors templates directory. Yeah.
Because there seems to be a directory missing.
So what we will do now, yeah.
Maybe you should copy the templates to
and
load, create a blueprint in the other repo, in the orchestrator repo, in the orchestrator server.
Also there you need one.
Maybe you should do it there instead of a separate repo. That could help.
Okay.
Because normally there should be 4 directories and there are only 2 now.
Yeah, you're right. That's a good idea. Okay. So let's go one level higher and go to the orchestrator one. LS. CD. I know there is no orchestrator here, of course. This is not having an orchestrator one. Yeah. No, it doesn't make sense.
Okay.
But what I could do, the other thing I could do, in the demo, you typically can create you can copy like all the files you have been using. no, like this, opt code, and put them here, code GitHub, and then we go to jump scale, we go to templates, no, of course not, AYS 9, right? And we go to templates, and we go to demo, right? Will this copy the full directory and its content?
I know, you have to do -R and then
Recursive.
Yeah.
-R, small r.
Yeah.
And then like this, or I always forget.
it doesn't matter.
Doesn't matter, and put them in the directory actor templates like this. Should do that.
Oh yeah.
Yeah, let's try it. Ooh, what happened? Oh wait, I touched the screen. Control B1. Control B1. Okay, there we go. Good. Let's check whether it really happened. Okay, that's okay. CD, so ls demo, everything is there. Looks good to you? Okay. So now I'm saying that everything is there. So what I do now, if this don't work, we are blocked, I think. AYS blueprint, like this. Okay, so as a result, we see now, if we go to the repository, just checking the result, demo, that at least, well, the blueprint is there. And okay, I cannot show you, the blueprint is there, that's okay, but what I cannot show you, because that's a bug, as I explained to you before, I cannot list the services. So if I go there, it typically shows, okay, wow, this is nice. Okay, good. And this is the first time I see it. This is what didn't work in my environment. But here you see, and it's a very simple one, there is no relationship. There is one CN, and it doesn't depend on another service. We typically use the explanation mark. It's the equivalent of the double underscore you saw in the blueprint, right? Now, the actual container will only deploy when I do add to service, run, create. And again, I can do a follow to do it synchronously. And when I do so, what should happen is that this AYS service running here and running here will talk to the orchestrator on the other side, and the orchestrator on the other side will talk to AYS here. So you have these levels that should work. Well, if it works. And follow is with double like this, I guess. Voila, you say, okay, that's what I want. And yeah. Is this normal? That probably this needs to be installed first.
Oh yeah, it's important stuff.
Yeah. Okay. We forgot to.
Yeah, it needs the client to connect to the API.
Yeah. Is there an easy way to do that now, or? Is it?
I think we have to pull the repo and then install it.
Yeah. Should we do it now? For those that still want to watch. So how do you do that?
Maybe it's already there. We should check the GitHub and on 0OS. Was it there?
Not here. So what I will do.
And then we have to pull the repo.
Yeah, let's do that. So what I will do is I go to which repository do we need?
This one.
This one. Huh? So what we do is we copy the URL like this. The only problem is that my key is probably not loaded. SSH @ minus. Oh, it's public. I should not matter too much. This. Let's see. No problem. What I will do is simply exit. Oh, where did I exit now? Okay, not important. Control BD, exit. Okay, log in again and make sure that my key is loaded. SSH @ -L It's loaded. So if I zoom, go into this thing, I should have it. SSH add -L, right? It's loaded. Tmx add, Control B, check. Okay, but it's loaded, I hope. So what I need to do now, let's go to, well, let's do it here. Let's go to opt code GitHub 0S, but it's not there. Huh?
Yeah,
not,
have to create it.
We have to create it. So what we do is make there 0OS and then git clone the repository, right? Okay. And how do I execute the client now, or shouldn't I do that?
Oh yeah, we have to install it.
Okay. You know where? Huh?
Yeah.
I always forget. Is it done or is it done? Sorry for this long session. Huh? So some of you stick and some, of course, left, which I find totally normal. But well, I love the unplugged sessions, sharing everything with you. Yes, but I did it in the wrong place, of course, right? So I can move. Huh? So because everything is
here. Okay.
so move 0. Well, move. Do I need recursive?
No.
Move orchestrator to 0OS. Right, like this. Valt soms weg.
Ja, het zijn...
Ja, dat gaat ook gelukt hebben. Allee, jong. Allee. Things get to be slow on this system. It's a remote system. Huh? Allee. Good, Alice. Is there? This system is getting
Really
slow. Okay, it's what I want. So I go to orchestrator and then
PyClient.
PyClient?
Yeah. And then ls. So when you pip install.
Pip install.
-u. Big U.
U, like this?
I know. U.
Huh?
The U.
Ah, U, of course.
Big U. I don't know if it makes a difference.
Okay.
And then dot for current directory. It's using the setup.py file.
Yeah. But this is actually the Python client we have been using in the very first sessions to interact with the 0S node. The same Python client, of course, can be used for interacting with the orchestrator REST API. But as you see, things are slow on that environment, which slows down, of course, the demo, which we do only for Nicola and Abdul now. Thank you for sticking around. Okay. So let's see what we can do now. We go back to opt var cockpit demo, and we do again AYS blueprint. Now we already did that. AYS run create follow, right? And if it doesn't work, it doesn't work. But if it works, we know what. Is it no way? Is it because it expired maybe?
Yeah.
Already.
Or because you exited.
Huh?
It will be gone because you exited.
Uh-huh.
So we have to export it again.
Ah, export it again.
Do the export job.
Yeah, maybe let's do a tmux add because we can do there. And go to demo.
Or you can copy it from the blueprint.
Yeah, I can. So, yeah, you're right. Yeah, you're right, of course. But when I do AYS service list here, it will still work. Huh? Okay. Right. Okay. Good. So what we do here, AYS run create minus follow. Right. Nothing to do.
Ah, yeah, we have to delete the service first and execute it.
The delete, yeah, AYS service delete minus role, well, all of them, but in this case it's demo, right? Yes, AYS service.
First the blueprint.
The blueprint, again. AYS run create minus follow, final step, yes. And it is executing, so normally we should see, well, here things are happening, but not sure what it's about that.
No, it's something else.
It's something else. I'm a little bit surprised that he did open that in a new Python screen. Don't know. Let me go.
Maybe because of the follow?
Yeah, you're right. So, but I cannot detach now, I think. I can? No, shit. Control B, D. I can. So, tmux list sessions. Did he create a new one? Yeah. So, tmux add will he create still main? Yeah, and there we see that we still have the same error.
Yeah, it can connect.
Yeah. Okay. No problem. I think it was a good try of our part. I'm sure it will be something stupid connectivity related that we didn't check. Is somebody working on my machine in the meantime? Always funny. Sessions should be nested with care, of course. Who is doing that? Anyway, I think this concludes the session, and this basically also concludes the sessions, the 12 first sessions, where we clearly discussed a lot of stuff. We'll come back to you in the second half of August with at least a follow-up on this session, probably like a new session doing exactly the same, where I show you how to create an AYS template, how to use it, basically to interact with the orchestrator. And I make sure that we also have some visuals to better visualize exactly what we are trying to do, because I can imagine that this might have confused a lot of you, but rest assured that we know what we do. So thank you very much, and if you still have holidays like me, enjoy them, and I'm looking forward to see you back soon. If there are no questions, of course. Nicola, Abdul, if you have questions, it's your moment.
Not for now.
No questions?
Yeah, not for now, but
okay.
surely,
Thank you, guys. Bye-bye.
Thank you.